Hi YouTubers, this is me again. As promised, we're doing a new series today on buffer overflow on the Windows operating system. Yeah, so on the left hand side you've got your Linux machine. On your right hand side you've got the Windows machine, which we will exploit. Okay, so let's get going. So okay, just a bit of a background. The software, the application that we will compromise, it's called vulnserver. It's an FTP application which got a buffer overflow vulnerability. So okay, so what we'll do, we will start it using Immunity Debugger. Okay, Immunity Debugger it's just a debugger on Windows operating system. So okay, so this is the program. I can open it and start it. Okay, there's the program here running. What we need to do, we need to find out what is the IP address of the machine we will compromise. 101. Okay, did that. Can minimize this. Can do a netcat just to make sure it's on port 9999. There we go. You see, welcome to vulnserver. And okay, the command that is the command that we'll use to compromise, it's called trun. This is the command that got the vulnerability. Alright, so now that we know that, we will use our fuzzer. Okay, so I've got a Python fuzzer script here already. As you can see here, we're just importing the socket. This is a variable to define the machine we're attacking, the port. This is where our padding will go, like padding or aka data. That's where our data will go. And this is another variable defining the network socket, okay, that we need to communicate. And this is a variable making the actual connection to the server on that port defined. And then if you know about the TCP, the three-way TCP endcheck, for every packet that you send, you're gonna have to, you will receive some packet, you will receive some acknowledgement and so forth, because the TCP IP does a three-way endcheck, which is a SYN acknowledgement, and then sync acknowledgement and acknowledgement. Right, so basically what's happening here, we're sending something, and in the receiving byte, that's where our SYN and acknowledgement will go. But anyway, let's move on to the next one. Okay, so here we're sending, we're sending another network packet, using the vulnerable command, which is trun, and then we'll fill it up with data, and well, this is just next line, and obviously we're receiving again, and okay, and we're exiting. Yeah, that's basically what this thing does. So let's get the data. The way we'll get the data is we need to create a pattern with enough byte that we'll send to the server, because we need to find out where the offset is. Okay, the same way we did on Linux. Okay, you know what? Let me just do this. Locate offset RB. Yeah, there it is. It's right here. Alright, so we'll use this. Okay, let me just clear. We'll use this command. Sorry. We'll need to create one, and then we can give it 5,000. Okay, give it 5,000 like this. Now this will create 5,000 bytes. It's quite high. You know what? Let's just do 3,000 bytes. Okay, so we've got our 3,000 bytes. We'll take our 3,000 bytes like this. We'll put it in our fuzzer right here, and we close it. So this is the data that we'll be sending to the FTP server. Okay, as you can see here, we're saying Tron, and then we're saying Tron, and then we're adding our data. Okay. Alright, just give me a second. Okay, right, so yeah, okay, yeah, so we got our data there that we'll be sending to get the right offset. Okay, so now we just need to make this file executable. And then, yeah, now before we run it, okay, we'll just make sure that we restart the debugger that the FTP server is running. Okay, now we're gonna run this. Okay, alright, so it's ran, but you see it's not returning on our side. And when you have a look here, we've got an access violation at this address here, this specific address. Okay, so then what we'll do, this is the address that you need to take note of. So let me open up a new Notepad. The address is 396F. 396F4338. Okay. Now you will use this. Now, what is this address? This is it's an address in memory where the access violation has occurred. So this is basically the address where the offset is. Okay, so we're just gonna cancel that, and then we're gonna run a different command called offset -q, and then we put the memory address that we have -l, the number of bytes that we sent. Okay, now this will run through this and give us the right offset that we need to go from. There it is here, 2006. Okay, alright, so now that we know that, we're gonna restart again. We're gonna play it, and then we'll go back to our fuzzer. We will delete all that, and now we will say padding equals / okay, let's use the A character again. Okay, 2006 time, which is where the offset is, and then we're gonna add something else. Okay, I'm just calling it like that, add, but you could call it anything. And then I'll give it a different character later. I'll give it a B. I'm gonna time this by 4. This is a 32-bit architecture. Memory address is read in 4 bytes. Okay, so this will take us up to the offset, and then we will print 4 bytes to the return address. Remember the previous chapter. Okay, and on the return address we will have BB, 4242s. Okay, so now we'll say overflow equals padding plus heading. Okay, and then we'll send it here, overflow. Okay, that's about it. Okay, all right, now this has been restarted. The FTP server is running. Now let's run this. When we run this, we should get 42s as an access violation. Okay, there we go. Yeah, as you can see it here, we got an access violation at 4242. So now we control the EIP. That's what we want. Okay, so now that we know that, we're gonna kill this. We will restart this. The next step is to find, remember on Linux we needed to find a valid address in memory to jump to. So we'll do the same here. We need to find a valid address in memory, and ideally what you want to do, you want to find the address of a library, and ideally that library needs to come from the actual application, because then that will ensure that that address stays the same. Libraries that runs within a specific applications are static. They're static. If you were to get a library that runs outside of the application, which is an operating system, those addresses will change. Okay, so yeah, so you don't really want to get those. Although we could use one of those now, then it will work. But once the operating system restarts or the service restarts, we won't be able to have access to the machine again, using our buffer overflow. So just remember, always try to find the libraries that runs within the application itself. Now the way you do that is, okay, so we start, there it is. So what you do, you can run mona modules, enter. Okay, there's mona module stuff, and here you're looking for, oh god, we can't see properly because, okay, I'm gonna have to, okay, you know what, let's do this. I think this will be better. Make it like that, make this small like this, take out Windows, make it way bigger, that's it. Alright, this goes up, and this will come down here. Okay, but for now, because I just want to show you, okay, so here we are now, we're looking for, so these are the modules within the actual application. We're looking for one that got false, false, false on the safe SEH ASLR and NX compact and rebase. These are basically memory render. This is what controls, how the memory addresses change. So because all of the options here are set to false, this is a good one to use. Because if you use any other that's got true values here, it means that the memory address randomization yeah, randomization has been enabled, and the memory will always change. so we will use this. Okay, so what you're gonna do, you say mono, then you say find minus string, and here we are looking for the string e4, because this is the JMP, this is the jump to the stack address that we've got there. It's FFXE. So you're looking for that string. You're looking for that string in the module that you've identified, ess func.dll. Okay, and then we go enter. Now this will go, you know what, I think I need to make this bigger. Okay, now this will go and find us all the pointers that are pointing to this string here, which is a jump to the stack address that we need. So you can pick any of them, but we'll pick the first one. Just make a note of the address, the memory address that you need. Oh, I can just type it out here. Right. Let's type it out here. So, okay, we're gonna ignore the 0x, it's 62, 50, 11, AF. Okay. Now remember little Indian, so this goes in reverse because it's an Intel machine. Intel machines run in little Indian format. So now we need to put the address in reverse, 50x 62. Alright, so this is the valid address that we'll use. So the way we'll do this, okay, instead of, because remember this is the offset, and then now we will point to the valid address in memory that we need to use, and then and then underneath here I'm gonna have the shellcode which I need to create. It's msf, there it is. So this is the command I've got already in my history. So we use MS Venom, Windows shell, reverse TCP IP. We specify our IP address, we specify the ports, the ports we wanna receive the connection to, format PI Python script, and we're encoding this with Shikata. I just need to give me a moment. I just need to double check what my IP is. Yeah, there's 102. So we're good to go. You can run that. Alright, now this is the actual code that will perform the reverse TCP connection to our machine. Alright. Okay, so now that we've got that, we can put it here. Okay, so we've got the entire code there. So now we'll say padding GMP. I like calling it GMP. GMP, and then the actual code variable is called buff. Okay, now if I were to run this like this, it will fail because we need to pad a little bit, you know, to make sure that we get a no operation just before our code. So we're going to put that here, and the no operation hexadecimal value is 90. Okay, remember from our previous video. Then we'll time this. We'll time this by 16 for now, and then if we need to increase it, then we'll just increase. But 16 is usually good enough. So how does our overflow looks like? We're padding first to the offset. We're jumping to the valid address in memory. We're adding some no operation, and then we're executing our code. Alright, so that's basically what it does. So we're gonna save this. We're ready to strike there. And okay, what I'm gonna do, okay, yeah, ready to strike there. Then I'll come back here. At this point we don't really need Unity debugger anymore, so we can close that and we can run the server normally. Okay, and then we're now ready to launch. But what we'll do, we need to listen. Okay, 1443, which is the port that we need to. Okay, so now this is the moment of truth. So as I run this, it will give us a reverse shell to the Windows machine. Okay. Oh my god, my battery is running. Okay, let's go quickly. Let's run that, and boom, there we go. As you can see, we've got a reverse shell onto the machine, and this is the Windows operating system. As you can see, yeah, that's where we are. So we basically connected to the remote machine. And what's nice is when you have a look at the actual machine, you know, the program's running okay. All right, program's didn't crash, so it's good. Let me just pause quickly. Okay, yeah, sorry about that. I was just charging my laptop. Okay, so like I said, we've got a connection to the machine, and yeah, the exploit has been done. Alright, so remember what I was saying about finding the right library, which will enable you to always be able to connect onto that machine. Alright, we'll test this now. We'll restart Windows Server. Okay, we'll listen again. Okay, we're gonna wait for it to come back up. Okay, machine is back up. So let's say I had this application starting at startup, so it will start up automatically. So it will be there, and then from my machine, if I run it again, it gives me access to the machine again. So yeah, this is it. This is a perfect example of buffer overflow on Windows operating system. Yeah, I hope this helped. Yeah, I hope this helped you out. And yeah, keep on watching my channels. I'll upload a lot more videos, you know, on this topic and on different topics as well, especially in security. So yeah, leave some comment. You know, if you have different ways of doing this, you know, you can share it with me and with everybody. Okay, thanks for watching. Bye.